What's going on, everybody, and welcome to a video about neural networks that speak. Every voice in this video is generated from a neural network. I know people will claim they could tell immediately.
I could hear the difference. There's absolutely no way I would be fooled by this. I have some of the best ears. Not too big, not too small. Just right.
Give it long enough and you might realize something is wrong. But I think this voice is pretty convincing.
It's not a question of if there will come a time where we can trust audio or video. It is right now. We live in a time where almost all of our information comes from text, audio, and video only. Now all of this can be fake.
It's entirely possible that many things we've already seen or heard were faked like this. I wonder how people will use this technology. It seems like it would mostly be used for bad things. What can we even do about this?
The reaction of many will be to just ban things like this, and this is not necessarily the answer. The truth is impersonating others for nefarious purposes is already illegal. The bad actors from other countries do not care about our laws. They will add this technology to their arsenal of cyber attack weaponry. Citizens must remain vigilant wherever they get their information and must remain aware that the threat of fake audio and video is here now. We live in an era where most people get their information online and from many sources, including social media. While this has allowed for more freedom of the press, which underpins our democracy, it has also allowed for foreign agents to penetrate your flow of information.
That is why tonight I am proposing that we build an internet wall.
That is a horrible idea.
If we look at China or Russia, they do not have this
I
problem.
don't think you understand how this
This
works.
wall would stop the flow of bad information.
It might be the dumbest idea I have ever
the best wall you've ever seen.
Okay, but no.
This would be a beautiful wall.
Absolutely not.
People would come to visit just to see my internet wall.
No.
I estimate that the money made from tours to see the internet wall would pay for the internet wall in 10 years.
We invited this guy up.
The issue here is just like any fake news. Often the truth takes a long time to get out, and some people will just never see the correction. With the last US presidential election, we saw just how much fake information could impact us by clogging up information. And that was just with fake text. I wonder how much more destructive fake audio and video will be. Alright, and back to reality. Or is it? Just kidding. Or am I? Anyway, what I'd like to do now is show you guys how you could get started with this, what's involved, and hopefully simplify it a decent amount. I had no idea how complicated sound could actually be with spectrograms and things like Fourier transforms, all this stuff. So I'm not going to be getting too deep into the weeds, just kind of show you how you could do what I've done and kind of what I found. I'm by no means done with doing fake audio, and the next thing I'd like to do is fake video and then combine the two. So there's still a lot I'm trying to do, and I don't really feel like doing a line-by-line thing, but I thought I would share with you guys what I found so far. So with that, the model that I ended up going with is this DC-TTS model, which is, I used this code here, but it's based on the following paper, which, take note, was written in late 2017. So almost 2 years ago, actually. But, you know, the history of doing text-to-speech on computers is, and has always been, pretty much, someone goes into like a studio and records hundreds of hours of audio, and then we use things like digital signal processing, or DSP, as I'll probably refer to it from now on, to do things like working on the pauses between words and sentences, and then do things to do like the speech pattern and stuff like that. It's all these like tools and hard-coded, rule-based things for text-to-speech in most cases. Even when doing text-to-speech with neural networks, historically, people have applied more rule-based things to the output. Now, obviously, the dream would be to do text-to-speech without any of that, just simply throw in some examples, get output that is just awesome. So that was the goal, and also side goal is to figure out how can we do this and how quickly can we do this, and could we just do this with like anything on like YouTube? Like, could we just take just about any YouTube video and mimic a voice on that video? So with that in mind, this is the model I ended up with, but I did try other models, including Tacotron and Tacotron V2, and I found this one to be the best, which is kind of curious. And one of the things that you might notice if you've been reading and not listening, or both, is this says Deep Convolutional. That's right, it's a convolutional neural network. There is not a recurrent cell to be seen, which is also interesting because traditionally, you would think of a task like this to go from text to speech. Text is a sequence. Speech is also, it's not like a single scalar value, right? It's a sequence. So most of the time, you would think I would use a sequence-to-sequence model, which is a recurrent neural network. Nope. This is using deep convolutional neural networks with attention. Now, this is guided attention, which I'll explain in a moment. But interestingly enough, it's turning out over the last couple years to be the case that deep convolutional neural networks are actually outperforming recurrent neural networks at these sequence-to-sequence types of tasks. They're doing it and they're training faster and they're getting better results, and that's awesome. I'm not sure that I'd be ready to say recurrent neural networks are dead. We just need a better way to do recurrent neural networks, because the biggest thing is the amount of data that's required and how slow they are to train. So if we could speed them up, we might see good things. So for example, I recall using a recurrent neural network on like MNIST data. So it's not like recurrent neural networks aren't like they're just as I'm trying to think of like topic wide as a convolutional neural network can be. So I wouldn't necessarily write them off completely. Don't forget, neural networks themselves got written off completely not long ago. So anyway, yeah, cool. So what's guided attention? Guided attention is this. It's basically the assumption that everything is going to be linear. So the input to the output will always be linear, as opposed to consider a machine translation task where, let's say you're going from English to Spanish and you've got big house needs to translate to casa grande. Okay. Well, the adjective to describe that noun in English comes before the noun, but in Spanish comes after the noun. So it's not a linear relationship in all cases. Other words might be, but some are going to be flipped around. And so attention is there to actually help with this sequence to sequence, which was previously mostly used for recurrent neural networks, but now we're using them in convolutional neural networks as well. And it turns out with convolutional neural networks plus attention, we can do the exact same thing with the added benefit of doing it way faster. The other nice benefit that I found is the end result is just better. So really cool. So for example, I just want to play a quick example of, let me see where it is. Yeah, so of a text-to-speech that is pretty close to the typical ones I would find by training a mediocre sample size of, say, 600 samples. So I'm just going to play one real quick.
Python is the one and only programming language.
Okay, you might not even understand what is being said there, but I'll play it one more time. It's saying Python is the one and only true programming language.
Python is the one and only programming language.
So yeah, that doesn't work well. So that's Tacotron on 500 samples. One thing to note, Tacotron requires more like 100 plus hours of sample audio and weeks to months to train. So I did not do Tacotron justice. Also, there's now Tacotron V2. So just understand that that's just an example, but I wanted to show you because every time I've ever played with text-to-speech, that's about what it sounded like in terms of text-to-speech with neural networks. So there's something there. You can tell the neural network is kind of grasping onto things, but it's just not there. It's just simply not there. So then I trained this deep convolutional neural network with this guy's code. And I'll try to put a link in the description. If I forget, someone remind me. You can also just Google like DC-TTS GitHub, and I'm confident you'll find this page. But anyways, I trained this model, and this one is on the LJ speech data set, which is here, which is a female voice. I don't even know. I don't know if it's Kate Winslet's voice, because he's got these other sample audios. You've got Kate Winslet and Nick Offerman, and then I'm not sure whose voice it is, but it's a singular voice. You need to train with just one voice, otherwise you'll get a meshing of voices, which maybe that's what you want, but probably not. Anyway, I used the LJ speech data set and trained for, I want to say about like 3 days. Like the first one, so this model has 2 networks. I'll explain that more in a moment. The first one took about 1 day. The second one took about 2 days. And this is the result that I got.
Now this voice is quite good in my opinion, and it was trained with many hours of sample audio from an audiobook.
Okay, so that is still a little robotic. You can, if you really pay close attention, you can kind of hear these weird little fluctuations. With somebody who knows more than I do, I really don't know much about digital signal processing and all that stuff. Someone who's really good at it could fix that voice and use like something really specific probably for that voice and fix it. But this is straight from the DC-TTS model output from here on GitHub. And that's pretty good. mean, that's clearly a person. We would accept listening to that audio. I think I was pretty staggered by those results because I've never seen a text-to-speech model produce such results besides Tacotron, which is a big pain to train. Now, that data set consists of 13,000 samples, and it's about 24 hours total of audio. It's a lot of audio. So my initial thought was, what can I do this with YouTube, and how few samples can I use? So then I tried to use my own videos because I felt like if I'm going to fake someone's voice, I probably should do my own first and then do other people's. It's kind of like if you're a police officer and you want to have a taser, they make you tase yourself first. It's kind of the same thing. So my hope was that I could take my YouTube videos and then also take the caption file for the YouTube videos. So I tried that, but the problem is the caption file doesn't quite, like the timestamps on the caption file aren't quite right. And then the caption file also eliminates often things like and other like stutters and stuff. And so like it just, because of the guided attention, this is such an integral part here because the assumption is everything will be linear, everything will line up. We are saying with 100% certainty. So we need it to actually line up. So it has to be perfect. And unfortunately, caption file, no go. So then I'm thinking, well, maybe captions are that way because it's better for the person to read it. So you could read it faster if we don't include the stutters and stuff. So then it's like, okay, let's try using like Google's speech to text. Tried that. Similar problems. It would chop things. It would leave things out. It would fix stutters. It would get rid of ums and uhs. So then I'm like, well, I guess I'll manually transcribe this stuff. And I don't think probably anyone watching this video has manually transcribed audio, but let me just say, it is the worst thing. It is the most painful thing. I can't think of a thing more painful than transcribing audio. At least unless it's like really clean audio. So in my case, there's a lot of stutters. There's the this and lots of uhs, and lots of times I like repeat a word twice or three times, and sometimes it's like really hard to hear, and you have to go back and play. And like at least what I found personally is I just naturally will nix when people say and like a lot of times I just like don't even hear it. So I'm sitting here typing it out, and then usually I'd play it back one more time or two more times after it was fully typed out just to make sure. And it was just staggering how many times I would miss things, even like twice I would miss things when I'm like really trying to pay attention to it. So really interesting and also just painful to transcribe things. So then I'm like, oh my gosh, because the LJ speech data set is 13,000 samples. I was finding I could do about 100 samples an hour transcribing. And then I could do at max about like 200 a day. Beyond that, it was like just killer, just too brutal. And so I do the math. That's 2 months to get a new voice. And cool. Truck outside my house. I love it. I love when you're recording. Like every time I record, big trucks have to come by. Okay, so after manually transcribing about 600 samples, the result I got was
Python is the one true programming language.
So that one's not too bad. There's a couple of small issues. One is it sounds like I'm underwater. The other one is you can hear these like little flickers in the background, and I think that's the model actually trying to recreate the sound of the keyboard, which is cool, but also not necessary. Don't really want that in the audio unless I want to add it after the fact. So it sounds better, but clearly we need more work, and it's just not great. It's not as good as that original voice. So then I'm thinking to myself, man, am I really going to have to do thousands of samples? Because generally, your initial results are going to be pretty good, and then it's this law of diminishing returns. So the more samples you get, the less, improvement you're going to see per new sample. So now I'm just like, oh man, what do I do? And then I think, well, what about transfer learning? So I decide, well, this model sounds good.
Now this voice is quite good in my opinion, and it was trained with many hours of sample audio from an audiobook.
So could I take that that model, right, with the two networks, do a transfer learn, could I get there? So my next question was, okay, well, like, time to look back at the model and figure out how everything's working. So let me explain briefly how this model actually works. So this DC-TTS model, basically the way it works is it's got two models. The first model is a text to MEL, is what they're calling it. And this is basically the conversion of text to a MEL spectrogram. Then the second model, and that's also where your attention is. Then the second model, this is your SSRN, or spectrogram super resolution network. And that one just basically kind of clarifies everything else. So my question was, what if I take that voice, that's this female voice, feed in, say, a few hundred examples of my own voice, and then do a few more thousand steps of learning, effectively just doing a quick transfer there? Could that work? And what I found was, first I had to figure out how many steps to go, and at least what I found was it takes about somewhere between 2 and 15,000 steps on model 1, the text to MEL. It takes about that many steps, and then on the SSRN, it really only takes like 1 to 4,000 steps. It really no more is required. I was kind of baffled by how quickly that one learns. I'm not really sure why that's learning, why the super, I guess because all that model really is doing is learning how to take a MEL and convert to this like super resolution. So maybe that's it, but I will say you have to train it. You can't not train it, otherwise the voice just will sound wrong. So what I found was to train. So for example, also before I show you some pictures, to train, let's say 0 to 15,000 steps, that's or like 1 to 15,000 steps, that's about like 3 to 45 minutes. It was like 1,000 steps per 3 minutes. So that's for model 1. And then to do model 2, it would take, to do 2 to 4, it would take about 30 minutes, okay, let's say. So all in all, about an hour and 15 minutes to train a new model. Now the question was, of course, how few samples could we do this with? So first, let me play the voice I got. I think this one's an early transfer. I'm just going to play it. I'm not sure.
I'm a human like you.
Yeah, this is an early train. It sounds like I don't actually have this properly labeled.
I'm a human like you.
And it sounds to me like it's a transfer of 1. So model 1, the text to MEL, but not the SSRN. But then after significant training on both sides,
we get a voice like this, which I think is pretty good.
So that sounds pretty darn close to me.
We get a voice like this, which I think is pretty good.
There's a few pronunciation issues, but again, the pronunciation issues will go away the more samples that you have. So in this case, that voice is off about 200 samples, so not many at all. And to transcribe that many samples, it would take maybe 2 hours. So what I did was we went from taking like over 2 months to create a new voice, brought that down to about 3.5 hours for anyone's voice, given that you have approximately 200 decent samples. So, and again, each one is anywhere between 2 and 10 seconds. I think the average is usually around like 6 or 7 or something like that. So about 15 minutes of audio. So you just need 15 minutes of audio. You can try with less, but then you get weird things. So for example, let me play this one for you.
Hello, mind this index to mine, not the machine.
So I call that one crisis of identity, because you can even hear it's like flipping back and forth between female and male voice, which is kind of funny. So, okay, so as I train, let me just show you kind of what I'm looking for. So I'm just going to grab Syntax 3 just as an example. Different voices seem to require different amounts of time, and if you're sitting here physically, you can kind of more manually, like if you see the attention going in the wrong direction, you can kind of fix for it. So one of the really cool things, I don't know, I'm sure some of you guys have seen attention graphs. So this is at 1,000 steps, 2,000 steps. You can see it starts at least to like form that line there. And then by about 4,000 steps, there's some serious attention here. And just for the record, like without this guided attention, this takes a lot longer to happen. So the fact that this is already happening by like 4 or 5K, like these are already these are already pretty darn good looking attention graphs. Like, dang. So now going backwards, I'm just going to start us to this. The female voice model stopped here. This is where I stopped it. Now you could train this one first a little more and then do the transfer. Like there's so many more things for me to trial and error here, and I've already trial and errored a lot of things. But this is where I stopped. So then 1,000 steps with a new voice, you can see the attention's it gets a little confused. The resolution gets quite poor, and then kind of loses attention towards the end there. But then by 187, it's also not really that great. 188, at least it's sort of improving. 189's improving, and then we keep going. I forget where I stop on this one, if it's 199. That one's pretty good. Not very good, right? Losing attention towards the end there. And basically, I just keep training until I see a pretty good one. Like, so for example, this one's pretty good. Like, look how yellow that is, man. Like, yellow is good, right? That's more closely aligned, basically. That one's bad resolution, and 199, I'm pretty sure it's the one I stopped on. Yeah. So I could keep going on this voice, but and you can see it kind of loses attention towards the end, but that's still pretty good, and that's the voice you've been hearing as my fake voice throughout this video. So anyway, that's just like an example. So you're just looking for these graphs to kind of tighten up and turn yellow and make it to the end without those, like a long line there, basically, to simplify it. So cool. So besides that, I think that's really everything I really wanted to show you guys. Now, moving forward, there might come a time where I do more of a line-by-line tutorial, but like I said, I'm just not done. And so if you guys want to take part in doing it, it's really simple. Download this person's code, okay? And then basically you go into the data set. So this LJ speech data set, if I click on this, I'm not sure why that's copied, but metadata contains all your transcriptions. So if I click on that, that's not what I wanted to open it with. Do I already have it? I don't have it open. Dang it. Let's just open it in text editor. You can see here, it's just separated by bar here, but also take note, there's two translations. I'm looking for the bar. I am not seeing, where's that bar? Okay, I couldn't find it on the first one, but there's the bar. Here is the bar for the number 6, basically. And so you could make your own. So for example, like when I was making my own audio, what I would do is I decided I didn't want, so I made my own by simply, I created a program. It would start with a label like this, bar, show me the text it wanted me to say. I would say the text, it recorded it with some Pi audio, and then output this file, and then it output the waves in this directory, and these are all your waves that match. So the file name here matches up with the name here. So if you wanted to make your own, that's how you do it. Now with the YouTube videos, like for Elon Musk voice and Donald Trump and Obama and whoever else I did, for those, unfortunately, I wish the captions worked. I almost kind of want to like throw away guided attention and just try regular attention, because it would be so much more cool to just automate the entire process. And I still think I can automate it, but the way that we did that was download the audio, split by silence, try to make the clips between 2 and 10 seconds long, split by silence, of course, and then I would play it and then transcribe it that way. So it's still very, very manual, and that's like that's the longest part of the task, and that's the only part of the task that really requires human input. So it'd be cool to automate that process for sure. But anyways, I did find out that you could definitely fake someone's voice with 15 minutes of audio, which is bonkers. I mean, that's just crazy. It's a very small amount of audio that you need, and the fact that you can do it in about 3 hours is also pretty crazy. So moving forward, what I'd like to do is continue looking to see if I can make these voices any better. So the fewer the samples that you add, it starts to pronounce certain things weird. Like, for example, if you try to make some of these other voices as I transcribe them, the term like neural network never came up. So when you would have them say neural, sometimes a neural or something weird that just didn't sound right. So wouldn't mind trying to figure out how can we get these models to be just a little better, and then maybe even use a base voice, or like have different base voices. So if you start with like a British base voice, male and female, a US base voice, male and female, and then start from there, I think you'd probably have better results. Because keep in mind, all I did was create a bunch of male voices from a female voice, a female British voice, and I didn't do any British people. Yeah, a lot of things that we could definitely test moving forward. But anyway, I thought this stuff was really cool. Obviously, there's all kinds of ramifications here. I think most people are completely unaware that this technology exists. Nowadays, if you get a phone call, you can spoof the phone number, first of all, but also we can now spoof voices. So you get a phone call from a family member, you have no idea, right? We all know that strange emails with suspicious links in them from family members we probably shouldn't trust. But if you get a phone call from your family member, you probably believe it's actually them, but it might not be. So that's pretty crazy. Also with like fake news and stuff like that, like in the last 2016 presidential election, I mean, it was so hard to keep up just with the amount of fake information in text form that was coming out. Now imagine like all the fake information that can come out with fake audio and fake video. Yes, we can validate this stuff, but it takes time, just like it does with the text. So it's almost like a social denial of service that I feel like went on during the last election, and this kind of stuff is only going to get worse. I mean, just imagine floods of fake information in text, video, and audio form. It's crazy. It's just crazy. I think this is a really important field that people are paying attention to. So the other thing I'd like to work on besides doing fake video in the form, I'd really like to create a text to video. So besides doing that, I'd also like to start working on adversarial networks to this. So just detecting fake audio and video. I think pretty much all social media websites and news agencies are going to need this to start validating the stuff that's coming through. Because I think it's going to be a big deal. I mean, it's already a big deal. And we saw how big of a deal it was in 2016. I think it's only going to get worse. So anyways, on that super light note, shout out to my most recent channel members. Thank you guys very much for your support. I'm going to attempt to say all of these names. I'm sorry if I mispronounce. Feel free to correct me in the comment section. Lugeson, Reddy, Casey, Meehan, Peter Freeman, Black Hawk, Pranit, Cathari, Jesse Jones, Payne, Max, Philip Wagner, Dylan Dye, Anup Dodamain, Anders Nielsen, Ayadel Ajayi, Jason Roberg, not Brian Bradley, and Carter Babin. Thank you all very much. All brand new members, welcome. Hope you enjoy the content. Okay, so questions, comments, whatever, feel free to leave them below. If you've got any suggestions on where to look, I know about deep fakes, but I'm not actually trying to do deep fakes for the text to video stuff. I'm quite honestly trying to completely generate things. So there is some research in talking heads, but I've never seen any code for it, and the papers are still kind of vague about the model. So I don't know if I'm gonna have to just try to figure that one out all on my own, and by on my own I mean me and Daniel. Yeah, it'll be really interesting. But any suggestions there as well, feel free to leave them below, or come hang out with us in discord.gg/Centex. Otherwise, that's it, guys. I'll see you in another video. Real or fake, who knows?